Hello guys, today I'm gonna start to talk about the momentum. How can I solve the problems of momentum? What about the momentum? What is the law of the momentum? What about the unit for the momentum? What about the types of collisions? How many types of collisions? What about the impulse? All of these things, inshallah, today we'll start to talk about each one of them. But first, let's start to mention and determine our objectives related to the updated syllabus from Cambridge. First, to define the momentum as mass times velocity, recall and use the equation P equal m times v. Define impulse as force times or multiply by time for which force acts. Recall and use the equation impulse equal F delta T equal delta mv. Apply the principle of the conservation of momentum to solve simple problems in 1 dimensions, because in 2 dimensions you will take it later in AS. Define resultant force as the change in momentum per unit time. Recall and use the equation F equal delta P divided by delta T. Okay, first, what about the momentum? Actually, the momentum related to a moving object. This means that when the object starts to move, so the object has momentum. But when the object is at rest, so its momentum equals 0. Why? Because momentum equal mass of the object multiply by its velocity, so m times v. So this means that the unit for the momentum is the unit of the mass multiplied by the unit for the velocity. So the unit for the momentum will be kilogram dot meter per second. So here we are, this will be the momentum. So now the momentum is defined by this equation, momentum equal mass times velocity. P represent the momentum, equal m represent the mass, and v represent the velocity. So this means that just multiply the mass by the velocity to get the momentum for the object. Actually, the momentum as vector quantity, it's vector quantity that has both magnitude and direction. So this means that the momentum may be in positive and may be in negative according to the direction of the velocity for the object. How can this happen? Let's see here. This is the first thing. As I said, the unit for the momentum are kilogram dot meter per second. And as we said, momentum is a vector quantity that has both magnitude and direction. And as we said, the momentum may be in positive or in negative according to the direction for the velocity of the object. This means that the object traveling to the right will be has a positive momentum, to the left will be negative momentum according to the direction you started to write at the beginning of the question. I'll tell you now. So this is the first part in our session. So we said the momentum for the object equal its mass times its velocity, and its unit is kilogram dot meter per second. So this is the unit for the momentum. Okay, here we have an example. As you see, we have drum truck, as you see in front of you, this drum truck, and here we have Mini Cooper. So based on the model 1, what is the mass for the dump truck? As you see in front of you, it's too easy. Its mass is 15,500 kilograms. So can write here 15,500 kilogram. So this will be the value for the mass. Mass is scalar quantity that has only magnitude without direction. Based on the model, what 2 quantities are required to calculate the momentum of an object? As we said, momentum equal mass times velocity. So we have to mention the mass of the object and we have to mention the velocity for the object to get the momentum for the object. So here we have m and v. M and v. Mass and velocity. How many times greater is the mass? How many times greater is the mass of the dump truck than the mass of the Mini Cooper? So he asked me to compare between these 2 cars, the dump truck and the Mini Cooper. Here, the mass of the dump truck is 15,500 kilogram, and the mass for the Mini Cooper is 640 kilogram. So this means that if I want to compare, So this means that if I want to compare between the mass of the dump truck and the mass for the Mini Cooper, I have to divide 15,500 divided by 640 to get how many times? So we have here 15,500 divided by 640. So we have now 24.2. So we have 24. We have 24.2. He said how many times? So no unit here because he said how many times. So it will be 24.2. As you see, we have table. We have Mini Cooper here, and he gave me the mass and velocity. Asked me to calculate the momentum. It's too easy. Just multiply the mass by velocity to get the momentum. So just you can calculate it by multiplying the 640 times 40 equal 25,600. So it will be 25,600. What about the unit? Its unit will be the unit for the mass and velocity. So it will be kilogram dot meter per second. The second thing about the dump truck, he gave me the mass and the momentum, and he asked me to get the velocity. So you can use the triangle for the momentum, or just you can divide it. He said here P equal M times V. So no problem. We can draw the triangle. It's better for you. This will be the triangle for the momentum. Here we have P and M multiply by V. So he asked me to get V, so V equal P over M. V equal P over M. So just divide 23,250 divided by 15,500. So it will be 1.5. So this will be the speed, 1.5. And the unit for the velocity, meter per second. That's it. Examiner tips and tricks. Take care about the unit for the momentum, as I said, because the unit for the momentum is the unit for mass times unit for the velocity. So it will be kilogram dot meter per second if the mass in kilogram and velocity in meter per second. But if the mass in gram and the velocity centimeter per second, for example, so the momentum gonna be what? Centimeter or gram dot centimeter per second. So this is the first thing. The second thing, he told you that take care about what? Take care about the direction. The direction for the momentum may be in positive, maybe in negative, according to or related to the direction of the velocity. So you have to consider at the beginning of the question, yani before you start to answer the question, you have to consider in the problem. You can write, I'll consider that the direction to the right will be in positive. So this means that the direction to the left will be in negative, for example. Or I'll consider that the direction to the left will be in positive. So this means that the direction to the right will be in negative. So it's up to you. Just you can write at the beginning of the question in which direction will be in positive, which direction will be in negative. So this is what he said. So here, which direction is taken positive is completely up to you in the exam. As I said, in general, the right or upward are taken in positive, and down or to the left as negative. Okay. What about the conservation of momentum? Actually, if we have two objects collide with each other, after collisions, what will happen to these objects? We have conservation of momentum. We have law of conservation of momentum, which states that in a closed system, total momentum before collisions equal to the total momentum after collisions. So one more time, this is the statement of conservation of momentum or law of conservation of momentum. Total momentum before collisions equal to the total momentum before or after collisions. So this is the first part. Let's take an example. If we have in front of you these two balls, we have red and we have blue. The red one, its mass is V and its initial velocity is U. This is before collisions. And the second ball, which is the blue one, its mass is M capital and its it is at rest. So this means that its initial velocity equal 0. After collisions, we have the two balls, each one will move in a certain direction. The red one will move to the left with a velocity v. This will be the final velocity for the red one. And the blue one moves to the right. And it has final velocity v capital. Okay? How can I mention the law of conservation of momentum? How can I use the law of conservation of momentum in this case? Actually, I told you before you start to write the law of conservation of momentum, you have to mention the direction. Very important to mention the direction of moving the object or movement of the object. For example, here we have, I'll consider that the direction to the right will be in positive and the direction to the left will be in negative. So this means that U will be in positive and M capital no need because it's at rest. And after collisions, this V will be in negative because it moves to the left. And this V will be in positive because it moved to the right. Okay, so let's start to mention the law of conservation of momentum before collisions and after collisions. Before collisions here, no need to write anything about this one because it's at rest. So this means that it does not move. Its initial velocity equals 0. So momentum before collisions will be m times u, only this. What about after collisions? We have m multiplied by v, as you see, plus minus mv. It will be minus mv. Why? Because the direction of this red ball to the left, and I said or I mentioned that the direction to the left will be in negative. So this means that the total momentum after collisions will be m capital times v capital minus m small times v small. Why we have to add here negative or minus? Due to the direction to this red ball, because it moves to the left. And I considered before that the direction to the left will be in negative. So I can write this mu, total momentum before collisions, equal mv capital minus mv small. And like I said, I add here negative due to the direction of the red one to the left. So this means that its momentum will be in negative, as you see in front of you. Let's talk about the types of collisions. Actually, we have two main types of collisions. We have elastic collisions and we have inelastic collisions. Elastic collisions, when two objects collide with each other, and after collisions, they move as separately from each other. Each object move alone with each other. Each object in a certain direction or both in the same direction, no problem. But after collisions, the two objects, each one separate from the other one. What about the second type of collisions? Actually, we have inelastic collisions. The inelastic collisions, two objects will collide with each other, and after collisions, the two objects stick to each other, and we can call this collision perfectly inelastic collisions. Let's talk about each one of them. The first one, elastic collisions. As you see, the elastic collisions, by the way, both momentum and kinetic energy are conserved. So here we have this ball, this one moved to the right, and it has v1, u1. Let's maximize here. So this will be v1i. So this will be the initial velocity for the first object, and this is the mass for the first object. This is the second object. Its velocity v2i to the left, and its mass m2. And I considered before the direction to the right will be n positive, as you see. What about after collisions? Each one move separate from the other one. So here, this will be, its velocity will be v on f to the left, and this velocity here will be v2f to the right. How can I use the law of conservation of momentum in this case? Actually, I have to write total momentum before collisions equal to the total momentum after collisions. So this means that m1 u1 plus m2 u2 equal m1 v1 plus m2 v2. Here I wrote instead of U1, V1I, no problem. You can write V1I or U1. Okay, so I can write here M1 V1I plus negative or minus M2 V2I. Why? Do you know? Due to the direction. Let's return back to the second object here. The object or this object move to the left. So here we have this velocity will be in negative. And here to the left, so this velocity will be in negative. This velocity will be in positive. This velocity will be in positive. Okay, so let's write it. So here we have M1 V1I plus minus M2 V2I. Why? Because here this direction will be to the left. So this before collisions. After collisions, here we have M2 V2F. This will be M2 V2F to the right, positive, plus minus M2 or M1 V1F, as you see, because it's to the left. So we add here negative. Okay, we add here negative and we add here negative due to the direction to the left. And as I said, in case of elastic collisions, when the two objects collide with each other, after collisions, each object move as one object, not stick with each other, separately from each other. Okay, so this is elastic collisions. What about the second type, inelastic collisions? Actually, in this type of collisions, momentum conserved while kinetic energy not conserved. Perfectly inelastic when two objects collide with each other, and after collisions, they stick with each other. So they move as one object with one final velocity. Why? Because they stick with each other after collisions. So they move as one object that has one velocity or one final velocity. So we can write the equation like this. If I start to use U1 and U2, so it will be M1 U1. This is for the first object plus M2 U2. So here all of them before collisions equal after collisions M1 plus M2, all of them multiply by V. V now represent the final velocity for both objects. Why? Because the objects stick with each other. So they have only one final velocity. If you want to use the initial velocity as U1, no problem. If you want to use it as you see, V1I, no problem. It's up to you. But take care about the direction. Actually here, if we start to write, rewrite the equation one more time by adding the negative sign or positive sign according to the direction, let's write it one more time. This is the first object to the right, so this will be in positive, and this will be what? In negative. Here, the final velocity will be in positive. So let's write it one more time. So we have M1 U1, okay, plus and bracket minus M2 U2 equal. Why we add here minus or negative? Because we have moving to the left. The object or the bar is moving to the left. Equal M1 plus M2, all of them multiplied by V, which is the final velocity. So this is what we said, ya shabab. So here, as I said, we have two types of collisions. We have elastic collisions and we have inelastic collisions. But take care. Before you start to answer the question, you have to mention this collision, any type. Is this elastic collision, or is this inelastic collision, or perfectly inelastic collision? I have to mention first. Then I'll start to write the given, and after that I'll start to mention the direction, and I'll consider maybe, for example, the direction to the right will be in positive, as we said. The direction to the left will be in negative, and it's better to write this before you start to answer the question. Okay, here we are, an example. This will be the example. A 10 kilogram stationary gun is loaded with a 10 gram bullet. It is fired with the bullet traveling at 100 meters per second. what is the recoil speed of the gun? Actually, as I said, let's mention the given first. Okay? So I'll start to represent the gun, or G for gun, and B for bullet. Let's start to write the given. Here he said, a 10 kilogram stationary gun is loaded with 10 gram bullet. It is fired. Okay. This means that I have to mention first, he said, the law of conservation of momentum, law or the total momentum before collisions equal to the total momentum after collisions. Actually here, the initial speed for both bullet and gun equals 0. Do not move. So this means that the total momentum before collisions for them equals 0. So just I'll start to mention the total momentum after collisions. So here the 10 kilogram for the gun. So here we have the mass for the gun equal 10 kg. Okay, is loaded with the mass 10 gram for the bullet. So here we have the mass for B equal 10 gram. I cannot write in gram, the mass in gram, because here we have mass in kilogram. So you have to convert between gram to kilogram, just divided by 1000 or multiply to 10 to the power of negative 3. So we have here 10 gram divided by 1000. Okay, it will be 0.01 kg. This will be the mass for the bullet. Traveling at 100 meters per second, this is the speed or velocity for the bullet. So this will be V for the bullet equal 100 meter second, negative 1, or 100 meter per second, the same. What is the recoil speed for the gun? So he asked me to get V for G. Just as I said, the total momentum before collisions equal to the total momentum after collisions. So this means that M1, or we can write G for gun and B for bullet. So mg UG plus MB UB equal mg VB or VG plus MB VB. As I said, this related to the total momentum before collisions equals 0. So this means that 0 equal mg VG. mg equal 10 kilogram times VG. What about VG? He asked me to get VG. So times VG. Okay. Plus MB VB. What about MB? MB equals 0.01 kilogram. So 0.01 kilogram times what? Times 100. Okay. So just you can get VG as subject. So now we have to get VG. It will be 10 V for the gun, the final velocity for the gun, equal negative 0.01 times 100 will be 1 here. So we can get VG will be equal 0 or negative 1 over 10, 0.1. What about the unit? Meter second, negative 1, and it will be in, it will be what? In negative. So this will be V for the gun. So this will be the recoil speed for the gun, because the gun moved backward in the opposite direction. So it is in negative sign, as you see. So here we have when these two freight cars of different mass collide and couple, what will be the resultant velocity as you see in front of you? Actually, we have to mention the velocity and mass for each one of them. But before we start to mention that, I have to mention what is the type for this collision. Is this elastic collisions or perfectly inelastic collisions? Actually here, ya shabab, he said when these two freight cars of different mass collide, what will be uncouple as you see? He said, what couple as you see? So here, stick with each other. After collision, stick with each other. So this means that we have inelastic collisions. Inelastic collisions. So I have to use M1 U1 plus M2 U2 equal M1 plus M1 bracket multiply by V. And V will be the final velocity يعني to all the two cars with each other or both cars. So here this will be, طبعا he gave me the mass in ton, no problem, and the other mass in ton, so no need to convert, and the mass in meter per second. So for example, if I write here, this will be M1 and this is U1 and this is M2 and this is U2 stationary by the way. So M2 times U2 will be 0 and this will be final velocity for both cars because they collide with each other. So this means that we have here M1 U1, okay, plus M2 U2 equal M1 plus M2 multiplied by V. Okay, so M1 will be 10 times 4 plus M2 will be 30 multiplied by 0 because it's stationary as you see, does not move, equal M1 plus M2, 10 plus 30, all of them multiplied by V, and he asked me to get V. So here this will be 0. So 4 times 10 equal 40 equal 10 plus 3 equal 40 V. So this means that V equal 1 meter per second because the mass or the velocity meter per second. So this will be the final velocity for both cars because he asked me to get the resultant velocity for both cars. That's it. Let's talk about the impulse. Actually, when a resultant force acts on a mass, the momentum for this mass or the momentum for this object will change. How can? Let's talk about the impulse. What about the impulse? Impulse actually equal the force multiplied by time, F times delta T or F times T, and it will be equal to the change in momentum, يعني delta mv. So this will be the impulse. So the impulse equal F times T equal delta mv. Delta mv change between final momentum minus initial momentum. If he gave you two velocities in the problem, you have to get delta, which is the change in momentum. Just subtract final momentum minus initial momentum. So this means that here we have F, I can write it as subject, will be equal to the mv minus mu divided by delta T. Divided by delta T. So this will be the equation here. So we have here impulse equal force multiplied by change in time equal change in momentum. And by the way, I can mention the unit for the impulse, which is the unit for force multiplied by the unit for time. So it will be Newton dot second or kilogram, unit for mass, times unit for velocity, kilogram dot meter per second. So you can use this or this, Newton dot second or kilogram dot meter per second. So these are the units for the impulse. These are the units for the impulse, equivalent to each other. So here, as I said, I can write F equal mv minus mu divided by delta T. This will be the force. Actually, by using this rule, I can mention the relation between the force and the time. Actually, we have inversely proportional between force and time. So this means that by increasing the time, the force will be reduced. Or by decreasing the time, the force will be increased. This is very important. I can use it in safety in cars. The relation between time and force, which is the inversely proportional between time and force. So this is the first part. I'll tell you many examples about that. So this is about the impulse, as I said. The impulse equal to the force multiplied by time for which it acts. And this will be the rho for the impulse, force multiplied by time. And after that, Ft equal mv minus mu, or delta mv. Just you get the difference between them. Okay. As I said, between force and time, we have inversely proportional. And I can write here F equal, as I said, mv minus mu divided by delta t or t. So as you see, we have inversely proportional between force and time. And as I said, I can use this to design safety into cars. Used to design safety into cars. How can? For example, you know the car has shape. So for example, I have two cars. This is the first car. And this is the second car. So the first car, this is the first car, and this is the second car. And by the way, the driver here in this point, the driver here in this point. Okay. So I can ask you, which car is more safety for the driver? Use the first car or the second car? As you see, this is the position for the driver. Try to think about it and return back to me. Yes, actually, using the second car, more safety for the driver. Why? Because as you see, you have designed to be crumple in front of the car, as you see. So if the accident happen at this point, yani you have here another car, and accident will happen, collide with will happen with other object. So here we have smaller time. The time will be smaller. The smaller time for collisions. So what will happen if we have a smaller time? So it will be, we have more force will be affected on the driver. Okay, but if we have here this car designed to crumble, as you see, so if the collision happen here, it will take many times or more times to reach the driver. So here you have more time. So more time will be less force. So it will be safety for the driver, as you see. So this is an example or an application about the impulse, the relation between force and time, which is inversely proportional between them. Also, we have many examples about that using seat belt. Actually, it's better or it's important to use the seat belt. Why? I said because by wearing the seat belt, this will increase the time of collision with the parts in front of the driver. It will take too much time, or it will take more time to reach the upper part of the driver of the car. So by increasing this time, the force on the driver would be reduced. So it would be safety for the driver. Okay, so it's very important for wearing the seat belt. As I said, that will be the seat belt. So here we have design safety into cars, and also using the helmet. You have to wear the helmet because this will increase the time for collisions and decrease the force on your head. So here I can write this: F net equal delta P divided by delta T, change in momentum divided by change in time. Okay, working example. At 58-gram tennis ball moving horizontally to left at speed of 30 meters per second is stuck by a tennis racket, which returns the ball back to the right at 20 meters per second. Calculate the impulse delivered to the ball by the racket, and double I state the direction the impulse is in. So please try to pause the video and try to answer this question and return back to me. Okay. He said he calculated the impulse delivered to the ball by the racket, as you see in front of you. First, I have to mention the impulse. Here we have directions. First, I have to write the given as I said. He said 50 gram tennis ball. I have to convert from gram to kilogram divided by 1000 or times 10 to the power of -3. So it will be 0.058 kilogram. To the left, as you see, and its velocity will be 30 meters per second. Okay, it is struck by a tennis racket, which returns to the ball back to the right at 20 meters per second, as you see. So first, you have to consider what about the directions. The direction to the right will be in positive or the direction to the left. For example, if we started the first direction, which is the left, to the left, in positive. So this means that the direction to the right will be in negative. For example, if I wrote here this direction, which is the initial direction, 30 meters per second to the left, will be in positive. So this means that this direction to the right will be in negative. So just to get the impulse, as I said, impulse F times T equal mv minus mu. So this means that the impulse will be equal to m final velocity minus initial velocity. Okay, so here will be equal m, which is 30, or m, which is 0.058, 0.058 multiplied by v minus u. So v will be negative 20 minus 30, because I considered at the beginning of the answer, about your answer, to the left will be positive. You have to consider, you have to write first. And then to the right will be in negative. You can write the opposite, no problem. It's up to you, as I said. It's up to you. So it will be equal, so 0.058 times 50 equal 2.9 equal negative 2.9. It will be Newton dot second or kilogram dot meter per second. It's up to you. If you want to answer and change the direction, it's up to you. You can mention the direction to the right positive, to the left negative. It's up to you. But you have to write to mention the direction before you start to answer. So this will be the answer. Energy, work, and power. This is very easy lesson. It's theoretical lesson. Just it contains kinetic energy and gravitational potential energy. But all of these objectives are theoretical, as you see in front of you. So these are the objectives for the course, as you see in front of you. Okay, you can read it. And this about the supplement. What about the conservation of energy? Actually, it's too easy to mention the law of conservation of energy. Energy neither be created nor destroyed, but it can change from one form into another. It can change from one form into another. Energy, its unit is joule. So here, the energy is the capacity of something to do work. It's too easy. And it sometimes contains a store of energy, so this means that it is able to do work. But what about if it does not contain any store of energy, so it will not do any work? Okay, law of conservation of energy, as I said, energy cannot be created nor destroyed, but it can change from one form into another. It's too easy. You have many examples about the object in vacuum. So what about the change in the energy here? Gravitational potential energy change into kinetic energy. Because as you will see, the gravitational potential energy related to the height from the ground. So if we start to fold the ball from up to down, so we have gravitational potential energy change into kinetic energy. And what about the gas cooker? From chemical to internal or heat energy. Also, we have LED, which is the light emitting diode, from electrical to light. We'll take it later. Here we have many examples for the energy store. As you see, you can read it. It's too easy. No problem, I said. It's too easy for you. And also energy transfer. Okay, let's talk about the gravitational potential energy. What about the gravitational potential energy? In the old syllabus, its symbol is GPE, but now its symbol is EP, gravitational potential energy. Gravitational potential energy related to the height from the ground, as I said. And EP equal mgh, equal mass of the object, multiply its gravity, which is 9.8 meter per second, multiply by h, which is the height from the ground. So here, as you see in front of you, here we have the ball up. So we have, this will be the height for the ball to the ground. So the gravitational potential energy for the ball at this point will be mgh. But here at the ground or above the ground, its gravitational potential energy equals 0. Why? Because there is no height from the ground. So take care, the gravitational potential energy related to the height from the ground. This means that, for example, if I have here a place, and this will be the ball, right? So do you think which ball has more gravitational potential energy, the ball number 1 or number 2, related to the height from the ground? Here we have directly proportional between height and gravitational potential energy. This means that more height from the ground, it has more gravitational potential energy. So this will be the answer. The ball number 2 has more gravitational potential energy than ball number 1 due to the height from the ground. By increasing the height, so the object will has more gravitational potential energy. So this is the law for the delta EP equal mgh, mass times 9.8 times delta h, which is the change in height. Kinetic energy. Actually, the kinetic energy related to the moving object or the movement for the object. And its symbol is EK, not KE. Now in the new syllabus, we have EK, which is the amount of energy an object has as a result of its mass and its velocity. Mass and velocity. So this is the definition for the kinetic energy. And it has this formula, which is EK equal half mv square, half times mass times square of the velocity. And it's measured in joule, even kinetic energy or gravitational potential energy or any type of energy, measured in joule. So this means that we have directly proportional between kinetic energy and velocity for the object. We have directly proportional. By increasing the velocity for the object, this means that the kinetic energy will increase. And by decreasing the velocity for the object, its kinetic energy will decrease. Okay? I can give you a question about that. What happens if the velocity for the object is doubled? What will happen to its kinetic energy? Just pause the video and try to think about this question. Yes. If I start to increase the velocity for the object to doubled, it will be doubled. So this means that the kinetic energy for that object will increase by the factor 4. Why? Because the velocity when it is doubled, so it will be 2 multiplied by 2 or 2 to the power of 2. 2 to the power of 2 equal 4. So this means that EK or the kinetic energy will increase by the factor 4. Okay, worked example. Calculate the kinetic energy stored in the vehicle of mass this and speed this. No problem, it's too easy. You have here the mass and you have here the V, so we can get EK equal half times m times v square. So you can get the answer in joule, as we said. Okay, energy flow diagram, as you see in front of you. Actually here, energy stores and transfers can be represented using the flow diagram. This is the flow diagram as you see. Okay, so here if we start by the reactor as you see in front of you, and here we have the system or a steam generator and turbine. What about the steam generator? Just produce steam by or with high pressure to rotate the turbine. to move to the generator to produce electricity to the national grid, as you see. So we started from the nuclear reactor, producing more steam with a high pressure, and end with electrical energy, as you see. So this will be the flow or energy flow diagram. We started from the nuclear reactor, as I said, and the steam will move inside the tubes, as you see. And after that, it will pass toward or through the turbine, rotate it, and go to the generator to produce electricity in the national grid. So this is as energy flow diagrams, as you see in front of you. What about Sankey diagrams? Actually, the Sankey diagrams, as you see in front of you, the Sankey diagrams, we can use it to represent energy transfers. We can use it to represent energy transfers. Actually, we have energy input and we have energy output. We have energy input and we have energy output. And also we have wasted energy. So we have energy input, energy output, wasted energy. So here, this means that if you return back to this diagram, as you see, we have input energy and we have output energy. The output energy will be the sum of the wasted energy plus useful output energy. All of them equal to the input energy, as you see. So this is input energy, and here we have useful output energy, and here we have waste energy 1, waste energy 2, or more than 2, waste energy 3, even. And by adding all of them, it will give me the input energy. Let's solve an example about that. So here we have total energy N equal useful energy out plus wasted energy, as I said. Worked example. An electric motor is used to lift a weight. The diagram represents the energy transfers in the system. Here we have energy input equal 500 joule and the useful energy output equal 120, and this will be the wasted energy. He asked me to calculate the amount of wasted energy. Actually, as I said, we said 500 equal 120 plus wasted energy. Wasted energy. So this means that the wasted energy equal 500 minus 120 equal 380 joule. This will be the wasted energy. Okay, thank you so much for watching the video about the energy and our session today. If you have any question, please just write in the comment. If you have any problem, just tell me, please. Thank you so much and see you in the next session.